Solve using the quadratic formula. So the very first thing that we need to do if we are going to solve using the quadratic formula is be certain that our equation is in the correct form, meaning it needs to be in descending order. So the first thing we need to do is bring the 8x over from the right to the left. So right now it is positive on the right, so on the left it will be negative. So 3x squared minus 8x minus 1 equals 0. Note that it's in descending order according to the exponents. That's what we're looking for. That means that A is 3, B is negative 8, and C is negative 1. So now let's write the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if a is 3, b is negative 8, and c is negative 1, we're ready to make substitutions here. So x equals the opposite of b, which is 8, plus or minus the square root of b squared. Go ahead and just square the negative 8. It's 64. Minus 4 times 3 times the negative 1, all over 2 times a, which is 6. So underneath our radical sign, we have 64 minus 4 times 3 times negative 1. Notice there's two minuses. So those two minuses are going to make a plus. So we end up with 8 plus or minus the square root of 64 plus 12. 64 plus 12 is 76. So we end up with x equals 8 plus or minus the square root of 76 all over 6. 76, let's make a factor tree or factor ladder, whatever you prefer. 76 is divisible by 4. So 76 divided by 2 is 38. Divided by 2 is 19. So it's 4 times 19. So that means that if it's divisible by 4, a 2 is going to come out. So 8 plus or minus 2 square root 19, that last factor of 19 remains, all over 6. We can take one last step here to simplify, remembering that 6 is the common denominator for both terms. Therefore, our final answer, dividing everything by 2, is 4 plus or minus 1 square root of 19 all over 3. That is your best and most simplified answer for number 1. Let's do it again for number 2. 2, 1, and none. It's ready to go. It's in descending order. A equals 11, B equals 5, and C equals 2. So we've got it set up. Let's substitute it into the quadratic formula, which we have written right here. X equals negative 5 plus or minus the square root of b squared. Remember, just go ahead and square it. It's 25 minus 4 times 11 times 2, all over 2 times a, which of course is 22. Underneath the radical sign, only one minus, so this part will stay negative. Negative 5 plus or minus, we get 25 minus 22 times 4 is 88. So first thing I see right here is we're about to get a negative number, and we'll be reminded about what that means when we get to the discriminant on the next page, but we will get imaginary answers here. So negative 5 plus or minus 25 minus 88 is 63, negative 63. So negative 63 is underneath the radical sign. So the first thing we want to do is bring out the I. We talked about that in class. So we have I square root 63. Then of course 63 is equal to 9 times 7. So that is why if we have the square root of 9 times 7, a 3 is going to come out. So we end up with negative 5 plus or minus 3i root 7 over 22. And 5, 3, and 22 do not have a greatest common factor. Therefore, that is our simplified answer. So on the first problem, we got two irrational roots. They're both real, but on this one, we have two imaginary roots because we have an I in there. Next problems. The directions say find the discriminant and give the nature and number of the roots. Remember, the discriminant is just the part of the quadratic formula that is underneath the radical sign. So it's just b squared minus 4ac. If the discriminant is greater than 0, we have two real roots. If the discriminant is less than 0, meaning it's negative, we have two imaginary roots. And if the discriminant is equal to 0, we have one real root. And that one real root is the vertex of your parabola. So number 3 is set equal to 0. It's ready to go. Let's list A, B, and C. So A is -4, B is 7, and C is -3. Remember, we're not solving here. We're just finding the discriminant. The discriminant equals b squared, so 49 minus 4 times A times C. Now notice 1, 2, 3. We've got 3 negative signs, so that is going to stay negative. So that is 49 minus 4 times 4 is 16, times 3 is 48. So we end up with 49 minus 48, that is 1. So if D is equal to 1, that means that the discriminant is greater than 0. It is positive. There are two real roots. Two real roots for number 3. Number 4, 2, 1, none. It's set up and ready. So A is -9, B is -7, C is -3. The discriminant is b squared, which is 49 again, minus 4 times -9 times -3. Again, there are 3 negative signs, so it will stay negative. So we end up with 49 minus, and we've got 36 times 3. 36 times 3 is -108. So we end up with 49 minus 108. And if we say 108 minus 49, I'm going to go to my calculator to be sure I don't mess it up. Minus 108 is -59. So our D value is -59. That means our D value is negative. There will be two imaginary roots for this particular function. So just to show you on the graphing calculator what that does look like, if I put this function in, y equals -9x squared minus 7x minus 3. If I look at that graph on the graphing calculator, which I've got to change my window here, if I look at that graph, what I see is it is located, it's going to be opening down, and it's located below the x-axis. It never physically touches the x-axis. That's why the roots are imaginary. Next, a model rocket is launched with an initial upward velocity of 45 meters per second. The rocket's height in meters after t seconds is given by the following function. H of t equals 45t minus 5t squared. Find all values for t. Remember, we're looking for t. T, of course, is time, for which the rocket's height is 25 meters. So h of t equals 25. We want to know what's t. So what we're going to do here is take our function, h of t. The first thing I'm going to do is notice that it is not in descending order. So if we write it in descending order, it's going to be, remember to keep that sign with the 5, negative 5t squared plus 45t. So this is the function in descending order. So let's bring that down. And think about what that would look like if we were to graph it. First of all, it would be opening down. And remember, I can put that plus 0 on right over there, and now it is showing us that the y-intercept is at 0. So we're talking about a model rocket, and visualize what the graph of a model rocket launch would look like. So first of all, y-intercept is 0, so it's starting right there on the ground. It's basically going to go up and come down. So what are we looking for? We want to know when the height of the rocket is 25. So think about it. That's not necessarily 25. We want to know when is the height 25. We can find that vertex by using the vertex formula. Let's do that. Why not? It's a good review. Negative b over 2a. So negative 45 over 2 times negative 5. So that is negative 45 over negative 10. That is 4.5. So if we go to our calculator and put in 4.5 into the function, so remember that's the x coordinate of the vertex. We're finding the vertex right up here, 4.5. So it took 4.5 seconds for the rocket to reach its maximum height. Remember, the vertex will be the maximum point here. So let's plug in that negative 4 or positive 4.5. So negative 5 times 4.5 squared plus 45 times 4.5 plus the 0. We'll put it in there. The maximum height of the rocket is 101.25. So the rocket goes 101.25 feet into the air. We're not looking for that. We want to know how many seconds does it take for the rocket to reach 25 feet. So if we say this is 25 feet right here, we want to know these 2 points. How are we going to do that? We're going to set the function right there equal to 25. So 25 equals negative 5t squared plus 45t. And we don't need the 0. So what we've got here is a pretty simple quadratic equation that needs to be solved. Remember, in order to solve a quadratic equation, we need to be set equal to 0. So in order to do that, let's bring the 25 over. 0 equals negative 5t squared plus 45t minus 25. So as we discussed in class, look at all the numbers. They are all divisible by 5 all the way across. And because this is a negative up front, I'm going to go through and I am going to divide everything by negative 5. It's just going to make my numbers smaller and more manageable. 0 equals negative 5 divided by negative 5 is 1t squared. 45 divided by negative 5 is negative 9t. Negative 25 divided by negative 5 is plus 5. So we end up with a very much simplified quadratic equation here with a equaling 1, b equaling negative 9, and c equaling 5. So if we are going to solve this quadratic equation, it will look like this. So it's t, but x. Normally we say x equals negative b, but we're just going to go with t here. T equals the opposite of b, which is 9 plus or minus the square root of b squared, which is 81, minus 4 times 1 times 5, all over 2 times a. Now, because we're talking about a rocket launch, we need to get a decimal approximation here. And we don't necessarily want a simplified radical. So that's why when I keep going here, this is going to turn into 9 plus or minus the square root of 81 minus 20. That is 61, all over 2. So let's find out what the evaluation of the square root of 61 is. The square root of 61 is 7.81. So let's go with that. So 9 plus or minus 7.81 all over 2. So if we've got 9 plus 7.81, 9 plus 7.81 divided by 2, that gives us our first, or one of our answers. Our first answer is at 8.4. And then we can do 9 minus 7.81. 9 minus 7.81. divided by 2. We've got our other answer is 0.6. So if we're looking for these 2 points, knowing that we have a y value of 25, because that's the height of the rocket, when does it occur? It occurs at 0.6 seconds, and then again at 8.4 seconds. So those are the 2 answers for this particular problem. Remember, we are finding all values for t for which the rocket's height is 25 meters. So after 0.6 seconds, the rocket's height was 25 feet, and after 0.84 seconds, the rocket's height was at 25 feet. Next, we've got 2 inequalities to graph. So first of all, number 6, x squared plus y is less than or equal to 4. If we're going to graph these, we want to put it in quadratic form. So I need to take the x squared to the other side. So it's positive on the left, it will be negative on the right. So y is less than or equal to negative x squared plus 4. This is a very simple parabola to graph. If you need to find the vertex, then we need to put in a 0x for the b term, giving a equals -1, b equals 0, and c equals 4. When b equals 0, it's the easiest of all options because negative b over 2a is simply 0 over -2, which is 0. And if we put in a 0 here, we find our y value to be simply 4. So the vertex here is at 0, 4. So plot that vertex over 0, up 4. And then quickly flesh out the rest of the parabola. We can put in a 1. If we put in a 1, we get 1 squared is 1, times -1 is -1, plus 4 is 3. Over 1 up 3, which means there'll also be a point on the other side. And if we put in a 2, 2 squared is 4. The opposite of that is -4. -4 plus 4 is 0. Over 2, up 0, back 2, up 0. This graph will be solid because it has the or equal to right there. So here's our graph. And we are going to choose 0, 0. It is in the interior of the parabola. Does it make it a true statement? So you can best bet plug it into the original inequality. So that's going to be 0 squared plus 0. Is it less than or equal to 4? Is 0 plus 0 less than 4? Yes. That's why we are going to choose to fill in inside the parabola. That is the part of the graph that will satisfy the inequality. And just to verify, of course, this does go on forever, and the graphing would go on forever in that partition of the grid. Number 7, y is strictly greater than 1/2 times x minus 2 squared minus 6. This, of course, is in vertex form. So our vertex here is at opposite of -2, which is 2, and -6. So our vertex is to -6, over 2, and down 6. So, of course, the axis of symmetry is going right down the middle of that. So now, let's graph the rest of this. It's going to open up because our a value is positive. So when we make a little XY chart here, let's see what we get. So I'm going to plug in 0. It's always the easiest thing. It's also our y-intercept. 0 minus 2 is -2. -2 squared is 4. Half of 4 is 2. 2 minus 6 is -4. Over 0, down 4. So 1, 2, 1, 2. Using symmetry, I can plot another point. Let's also next plug in -2. And I'm choosing even numbers because I know I'm going to have to multiply by 1/2. -2 minus 2 is -4. -4 squared is 16. 16 times 1/2 is 8. 8 minus 6 is 2. Back 2, down 2. So it does not appear that I went back 2, up 2. I went down to, let's X that point, try again. Back to, up to, back to, up to. That's looking like a better parabola. 1, 2, 3, 4, 1, 2, 3, 4. Here we go. This graph will be broken because it is strictly greater than. Broken. There we go. There's our parabola. And now we're going to try 0, 0. Does it make it true or false? Remember, let's plug it back into the original given inequality. So is 0 greater than 1/2 of 0 minus 2 squared minus 6? So 0 minus 2 is -2. -2 squared, -2 squared is 4. Half of 4 is 2. 2 minus 6 is -4. So we'd already actually plugged that in right there. Is 0 greater than -4? Is this a true statement? Yes. So once again, we will be shading in here. So those are the quadratic inequalities. One last question. Let's solve this system. So first thing I wanted to show you is look at the graphs of both of these, and let's see how many solutions we actually have here. There we go. So y equals x squared plus 7x minus 3. This is just a very basic parabola. X squared plus 7x minus 3. That's the first equation. The second one is just y equals mx plus b form. It's just a line. So -4x minus 21. So here are our graphs. And it looks like I need to zoom out a little bit so we can actually see it. Let me do that. There you go. There's more. There's our whole parabola. And here's our graph passing through. So what I see here is that the red line is passing through the parabola one time at the bottom and also one time at the top. So we are about to get two answers here. And we're going to do that with algebra. That's the downfall of the graphing, is that we can't necessarily see it if it's at a fraction. So look at what we have here. We have y equals x squared plus 7x minus 3. We also know that y is equal to -4x minus 21. So if y is equal to y, then x squared plus 7x minus 3 must be equal to -4x minus 21. We're just going to set these two equal to each other because they're both equivalent substitutions for y. And this turns out to be a pretty nice quadratic equation. So if we have a quadratic equation, which we do, we need to set it equal to 0. So both of these terms simply need to go from the right to the left. So x squared plus 7x minus 3 plus 4x plus 21 equals 0. Combine the like terms, which are here and here. So we end up with x squared plus 11x, -3 and a plus 21 is plus 18 equals 0. And we don't even need the quadratic formula here because this is factorable. How do I know it's factorable? Because there are a pair of factors of 18, 9 and 2, that just happen to add up to 11. And of course, I'm able to do this because there is a 1 up front. So we can easily factor this into x plus 9 and x plus 2 equals 0. And we remember that anytime we're solving a quadratic and we factor it, we then set each factor equal to 0. So x equals -9, x equals -2. These are my two values for x, which we then need to take back. And I'm going to choose the bottom one. It's the simpler one. We're going to substitute them in and solve for y. So, all right, when x equals -9, y equals -4 times -9 minus 21 That's 36 minus 21, y equals 15. So our first point of intersection is negative 9, 15. So that was the one that was way up high. Next, plug in the negative 2. Let x equal negative 2, y equals negative 4 times negative 2 minus 21, y equals 8 minus 21, y equals negative 13. So this is the one that's way down low. 2, negative 13. There you have it. That's one of every type of question that's on our test. See you soon.